Hey Luke, hey, how you doing? Good to see you. I'm just going to put on an intro track. Be right back. If I can find the damn thing. Oh, here we go.
I'm a man with a mission. 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 man with a mission. I'm a man with a mission. I'm a man with a mission.
Hey, right. Let's get going. Just made it in time. I said the streaming forecast would be by 10:30 usually, and so there we are. Is that self-fulfilling prophecy? I really probably, I don't know. Yeah. HAL Open Fi project.
Opening.
HAL Run Nugget window.
Running Nugget window server.
Okay. Nice start there, HAL. Very good, very good. HAL run program. Wow, 3 out of 3. So this is where I got to last night. There was a major milestone. There was a major milestone in I have multiple objects working. So the Phi language has been able to have something that has something that looks similar to objects, although I hate using that term. Yeah, in this case I've got a bunch, 8 cubes. You can see them moving really, really slowly in this area over here. That is quite slow. But I'm not too surprised that it's slow, because it's a totally inefficient implementation. I've got to prove the concept first. But this is the program, yes, at the beginning what it does is clear the graphics, and it also makes the cubes, and each cube is given a name, because the Phi language doesn't have memory allocation. It doesn't have a bunch of things that other languages have. It doesn't have memory allocation. It doesn't have a program counter, has no control flow statements. It doesn't have an if statement. Because it doesn't have a control flow statement. So yes, and yet you can still do anything you like with it. In this case, what I'm doing is I've got 8 cubes, and when they're created, this is like a constructor basically. So the equivalent of a constructor is in Phi is just any function that you wish to behave like a constructor, but what you can do is pass in the name of a variable. It's an identifier as the identifier's name, as opposed to as the identifier itself. If I make a function call and I pass in a variable, I pass in the variable, right? Okay, that's fine. The function takes the value of the variable. So in effect, yes, you could say it's pass a value, pass a variable by value, which is the default way that it works. This cube with an at, a variable with an at after it would be similar in idea to the ampersand in front of a variable name in C. But the difference is that the variable is different, because there are no addresses. Did I mention that? Yes, Phi doesn't have addresses either. What it does have is names. So yeah, that putting an at after the variable name converts it to the type, which is a variable name. And that is a concept that doesn't exist in other languages. That's why I was talking a little bit about that last night. That you can't in C say pass to this function the name of this variable. You can kind of fake it if you use a macro, and then the stringizing operator, hash operator. There is a hack that allows, which is the C preprocessor that allows you to do this, sort of. In C# you absolutely can't do it. It's actually impossible. So there's something you can do in C and C++ you can't do in C#. C# doesn't have a preprocessor. It is actually impossible to pass in the name of a local variable to a function. Just can't do it. So this concept of being able to pass the name of a I don't know if there are other languages out there that do it. I guess there must be. You often see it kind of faked by using strings. So, you know, you have some kind of reflection and you pass the variable name as a string, and then maybe you can access a variable by name, by a string, right? That isn't what this is. This is literally, there's a type which works at the runtime, which is the name of a variable. So this passes in that, well, it's not even the name, it's the identifier of a variable. So what this does is it passes in, instead of the value of cube1, it passes in the identifier cube1, which of course at this point doesn't exist. So that's the other point, you see. You can way that it's different to C or C++, ampersand, is you literally can't have the address of something that doesn't exist yet. You know, you can't. In this case, cube1 exists. This cube1 exists as the name of a variable, but the variable doesn't exist yet, and that's okay. And what happens is you pass in the name of the variable that you wish to hold the thing that is being constructed. So it's not a case of a return value from a constructor. So it is very, I mean, in the end, it's doing a similar kind of idea, a similar kind of thing, but it's actually doing it in a completely different way, a way that you can't actually do in C or C++ or C#. So what's happening then is that inside the function, this variable, this argument item, I'm passing in I suppose you could call it a literal well, it's a reference, which is, you know, a literal identifier. And so when this is executing, at item will be replaced by the actual reference, the actual variable. So this becomes make graphics cube1, and so on. So when we begin the program, we clear the graphics and we make a cube, or we make several cubes. And but when we're looking at making this cube, it goes, okay, call make cube with a reference to cube1, or the reference cube1, and 10 0 0. This goes in, okay, this is a reference to cube1 and 10 0 0. And on the beginning of this function, it makes a graphics cube. This communicates with the interface to the the library that communicates over the network to this viewer, which I made in Unreal, like it seems like an eternity ago. So that causes the cube to appear on the screen, right? And it also, on the beginning of this function, it sets the position to 10 0 0, right? So the position is fixed at the moment, and it sets the velocity to the x, y, z that were passed in to make cube. And thanks Luke. yeah, this is something I've been working on for a while. This is like a dream. This is like the culmination of my efforts in programming. So I'm quite proud of how it's turned out. It was a big thing yet last night when I fixed the final bug and I was able to have multiple objects. Previous stream before, I got to the point where it worked with one object but it didn't work with two, and then last night I fixed it. I'm only working on this on stream, by the way, so if you in the history on YouTube, you can actually follow the whole thing from when I started streaming. There's also the creation of this viewer. That's all on the there's the whole thing is there because I only work on this while I'm on stream. So what happens then is that at the beginning of this function it's set up all these variables. That all seems very simple. And then there's these two, and these are a little more complicated, because what I want to have happen with the cube that I've created is that I want it to add the velocity to the position on every frame increase, every new frame, right? But what I also want it to do is that should any of x, y, or z of the position change, it needs to call the function that updates the position of the cube on the viewer. So this is a fundamental point about the way that the program works, in that you have a rule, and there's a rule and then there's an action, or rather, let me rephrase that. A rule is composed of watches, which are in effect triggers, watching variables, and actions that are executed when any of the things which are being watched change, right? So this is basically saying, this part here is saying on change of any of pos x, pos y, pos z, then the action to execute is update the position. So this ensures that you'll never have it out of sync. If you move or if you change the variable, it will update. That's the way the language works. It absolutely will do that. If it doesn't do that, it means there's a fundamental bug in the language or in the virtual machine, right? I mean, that's the whole point, is to ensure that it's what it says. When this happens, do this. And so you're sure that whenever this happens, it will always do this. And you can see how that can be really useful for many things, including ensuring that lots of kind of race conditions, for example, can't happen. It's you can, to be fair, because you can construct with the language a virtual machine that behaves like a procedural language. It is entirely possible to create a race condition, but you really have to work hard at doing it. You have to actually create a virtual machine that is subject to race conditions. Otherwise, you can't really create a race condition. The only thing you can do is have a collision. That is the Achilles heel of this particular methodology. That is that you have a variable trying to be modified by two different paths in the same action, and that it would be, that's all stuff I'm going to investigate in the future and figure out, how to deal with that, best way of dealing with it. So anyway, on here, what that basically says, on the change of the position, update the position on the viewer. Then this one says, on change of the frame count, so that means when there's a new frame, add the velocity to the position. But these rules are not executed when the cube is made, because they are actually indirect rules, because they are add on begin. There's this add on begin that I put here, and so this says add a rule. It's basically saying add this rule on beginning. So on the begin, add a rule. And so what's happening is that when you create the cube, it adds rules for the execution of the cube. So it literally handles the addition of new stuff that needs to be done by literally modifying the program. The program itself is a list of rules. These are rules here at the global scope, and then there are rules inside functions. Okay, but essentially, you know, that's just a kind of like, that's a scoping thing, but in the end, the program is a set of rules. And so you can add rules to the program, and that's literally what happens. When a cube is added, in this case, it adds two rules. One for updating the visual position of the cube, and the other rule is for integrating the velocity on each frame step. And so that's a summary, a little recap of what this is about. And yeah, now it works. Being able to create an object, and what this actually means, that it solves the problem. And this was something that, you know, I was unsure about how to handle it, was how to make, in effect, object-like things, like for having multiple objects within a scene. Very slow at the moment, of course, because the implementation is horrible, because I'm building and designing the language and the architect, you know, I've been unsure about what kind of architecture I need underlying it. I have a choice right now, which is either to play with this. I'm tempted to do a little bit of playing, but I'm going to have to start thinking about refactoring. So I'm probably just going to have a bit of a play, try things out right now. The language has got a lot missing as well, so as I experiment, I'm going to have to sort of patch the language a bit and add features which are missing and so on. Hey, Karios, how you doing? Good to see you. So, yeah, new faces tonight. Well, you, Luke, are... I think it's your first time saying something on stream. So there's a new feature on the stream, courtesy of someone called Wagyu, who is in Lucerne. Yesterday actually made a donation so that I could buy a license to MapFling. So if you don't mind, what I'm going to do, let's see, my maps, here we are, and this is the map which started yesterday, the location of people, the audience basically. We had a whole bunch of people yesterday on. I mean, maybe there were other people as well, but these are the people who said hello. And we had quite a crowd in the end. We had, there's always Zag there in Texas, and then Mark, who's in Seattle, and then Adam in Vancouver, Rui in Portugal, Alessandro in Naples, Wagyu there in Lucerne, Deosian in the Netherlands, Lars in Belgium, and Mr. Unwondering in London. Mike is here. Hello, Mike. I forgot you, or Garcia. I forgot about you there in that list because you're over all the way in Melbourne. Why won't this move? That's interesting. It won't let me move. I need to edit the map. That's why. I need to go into edit mode. Here we are. So I believe Luke is in London. So we'll put another London one in there. Salad Gaming. And Karios, are you in the Netherlands as well? I can't remember. I think so. Let me know and I can add you to the map. All right. So here we go. Playing. Yeah, I want to play. Want to play with this thing a little bit and see what it does. Now, one thing I want to fix right now, because it's annoying me, is that currently negative floats are broken. Oh, Geneva, I got that completely wrong. My apologies. Well, you're near. You're near Wagyu then. Ah, yeah. That was right, yeah. Geneva. Oh well, not that near. There it is. Carius. There we go. Right. There. Right. So I'm just going to simplify for a minute because it runs pretty slow when we get to this point. That's all going to be a very interesting thing about optimization. Yeah, this is a long way to go because there's no. I have to all ideas of optimization and so on. I have to do everything really. So. Right. If I run this, how run program? How run program? How restart program? It was already running. So there we've got the cube, one cube moving away because the velocity of x, this is sort of like a coordinate system of Unreal. X at the moment is going away from the camera. Positive direction is away from the camera. You know, if I make that like 100, HAL restart program. HAL restart program. Let's see, so it goes way faster. But I want to fix the negative number problem because if I do -10, HAL restart program, I'd be expecting it to come towards the camera and it's going away. So let's take a look at that first of all. Now, what's odd is there were no errors. That's suspicious because it means it parsed it. Though I'm not entirely sure. I'm not entirely sure how it parsed it and there were no errors. Oh, wait a minute, I know why. Oh, yeah, okay. So the problem is that I'm using Antler 4, ANTLR, for doing the parsing. Postino, not yet. This is only since yesterday. So I think what I will do is probably run them Saturday to Saturday. Run this Saturday to Saturday, so we get everybody who was on a particular week. And I'm going to run it now. Otherwise, it just, yeah, it's got to kind of represent some kind of reality, I think, you know. So this Antler is actually very nice, but it is object orientated, of course. So that isn't so nice. It's a bit awkward how for doing the parsing you have to create functions that are called, you know, you need to override functions or methods, whatever they have to be overridden so that certain things which are visited as it parses a function is called. Now by default, or I suppose there's a way of doing it, but working on the template that the default template for Antler, what it does is that if you haven't implemented any, there's some reasons for it too, but if you haven't implemented any of them, right, then it just calls the default one. And the reason for doing that is because otherwise it won't traverse the tree. But the problem then means that you get a silent ignoring of things. So what's happened is that the parser must be not actually calling. I must have no function being called in my parser by Antler when there is a minus, the unary minus operator, and that's why there's no error. And because it's just calling the default internal implementation for that, it's in effect being ignored, and if it's ignored then we don't see a negative number. So what I need to do is add it, and all this talking as I describe it is really good for me because it's actually me thinking it through in a very clear way. So in some ways streaming is actually better, because and there is going to be a U minus. I need to find that first. Well, it's got, I just want to find where it is. It's variable, no, float. Let's have a look at a float. The definition of a float is a float. Yes, the float doesn't have a minus on it. So I am expecting to do the unary minus. That's it, this one. EXPR U minus is what is needed. So let me just first U minus. Oh, look, I did. Oh no, look at that. All of that theory, but it is actually adding U minus. So the expression there on line 2472, we have excon, that's expression constructor, add operator, U minus. Oh, so I'm going to just check to make sure that that's being actually called. Yeah, it's been called, and it's been called with something that I can't be bothered to try and use the debugger to show, but you can do this. We can do this to on here, and let's try that again. Hey Michael, how you doing? So Michael, you're in, correct me if I'm wrong, I want to say, it's difficult to remember everybody, but I think you're in Manchester, aren't you? So I'm going to add you to the map. You can just, I'm just going to go for it, and then you can tell me if I should move you. Michael, how are you doing? In fact, I now have a license for MapFling. I have a license for MapFling, which means that I can have an unlimited number of these, and there's some other facilities in there. I think I can give people colours. This is thanks to Wagyu from yesterday, who sent me the year's subscription for MapFling, the money for it, which wasn't, it's about £12 or so, so it's not like, he hasn't gone crazy or something, but it's very that was very generous, and that's given us because I probably wasn't going to bother to do that by myself, so cool, thanks to Wagyu. Yeah, we put the full map in, there we go. Right, so what's weird is that the operator is being added, and we can see it's minus 10. So I was wrong. It means the problem is somewhere else. When it's executing the expression, it's evaluating the expressions, I should say. You know, the evaluation of the expression is a complicated thing. I'm going to have to... Let's have a look at u minus here. See, look, unary integer operation. Yeah, but I don't want an integer operation. I need the... And this is a float. So maybe the problem is I never implemented... Yeah, look, I never implemented it for floats, but then I want to know why is it I didn't get an error. It should report an error. Well, let's put a breakpoint there and see if that's being executed. I'll restart program. Yeah, it does. Let's go into there. Ah. Well, okay. So the reason is that the way I've done this, which is cheap and cheerful for now, all of the expression calculations are all done using, I think, what are commonly called atoms in this, but I called them, you know, expression item, EXPR item. When I refactor, I'm going to rename that, I think. And that can hold multiple types. So the way it can hold it like an integer, it can hold a float, it can hold anything, and the way with primitive types is there's a variable that's an integer and a variable that's a float, and basically in all cases it's calling unary integer operation and it's negating the integer, which doesn't actually touch the float. So as a result, that's why it's doing nothing. So the issue there is, why does it call this? It calls this because I do not check the type. So right now the bug, or the issue is, I do not check the type of the thing that I'm doing this, applying this operator to. In the evaluation, yeah, I need to check the type. So if I do negation of a float or negation of it, I'm going to put in a switch statement here. I think that's what we need. Switch on well, eop. Oh, right, because I have to look at what's on the stack. Integer operation. No, all right. It's actually a lot easier if I do it this way. Unary operation, and we'll worry about the types inside there. This unary integer minus needs to be renamed unary minus. Okay. I should have renamed that. All right, let's do it this way. So I go to that and I say rename unary integer operation to unary operation, and I'm going to rename unary integer minus I tend not to use this thing, it's just habit, because I never really trusted it, but I'm going to try trusting it. So when you have been using, you develop habits where you don't trust certain things in a tool, and then even when they fix it, you carry on not trusting it. So, okay. Want to stop debugging? Yes. Let's look at this function. I should be able to go to the definition of it. Right, so this is the right place for that, because now I'm operating on the stack. The left item, so what I'm doing is popping off the stack Yep, I'm taking the item off the top of the stack, which is the thing that I'm negating. Then there is this integer op func. It's yeah, that's not so nice, because then I can see that I actually can't do it that way. So backtrack, that was a bad idea. Because I'm passing in a pointer to a function. I need to see what is being worked on, and so I'm going to have to peek the top of the stack. Do it here, that's fine. Right, to peek the top of the stack like that, and then I'm going to do a switch on the type left dot op. The operator in an expression item is actually the type. Well, it could be it's a type, or it's a type, or it's an operator. So it's sort of like an identifier of what the thing is, I suppose. So in this case, I need to set up a case of operator, and we can look for an integer. Let's do the standard pattern. Don't do that without. I always just do that now whenever I'm making a case statement. I don't even think about it. And so, you know, adding the break in. So unary integer operation. This is fine. I don't see anything wrong with that. That's cool. And then we can go and do the second one. So we do operator. It's called float instead of float, because otherwise it conflicts with the float keyword. And so in this case, I'm going to have to unary float operation, unary float minus, and yeah, it was in the wrong place. We've got a switch inside switch. Yep, that seems fine. And then we need to implement these. So let me go to this guy, and we're just going to copy it out. Unary float operation, unary float op func. No, I suppose I could have done it in a different... Well, I'm going to do it this way, so it's fine. Right, so stack on there, we get this off, we do this. Instead of this left integer, right, finally, we get to the point. This needs to be, well, L float. Yeah. L float. Sort of... Right. Intermediate, left op, integer, right, no. The type will be a float. The integer is not what I use here, and this needs to be a float. So this does the a unary operation on a float. Which is fine. And then if I come back to here, I can look at u minus of the unary integer minus. Let's go to the definition of that. And this is there. Great. And this is all messy when you're doing making a language, because you can see how many of these you get, and then I suppose you could try. One could try and make this use templates, but frankly, I don't think it's worth it. It's just an additional confusion for very little reward. So this is now a unary float minus function, which is create. Let's see if this can HAL compile program. HAL next error. So what we have here is syntax error identifier. Of course, it doesn't look like there's any... Yeah, it really doesn't look like there's any thing wrong with it. But what's wrong with it is that clearly this doesn't exist. It doesn't say that that's the problem. It says syntax error. It's like, how can it be a syntax error if it's, the problem is this doesn't exist? It's just those peculiarities. Unary float. Unary integer operation. Right, let me see where this is. Whoa, whoa. There we go. Unary integer operation. Unary integer. Ah, no, I haven't created this type. That's why. Yes. I need to also make one of these. Float express blah 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 blah, and this also needs to be a float. How compile program. Hey Garcia, I'm going to turn on Radeon Tube when I have enough material collected that I can put something broadcasting 24/7. We can actually take a look at. This is one of the reasons why I started creating some of those HAL things that kind of grew out of this desire just to create content. So I'm either making new content, I'm looking in the archives. It'll come online when I have enough. What I have right now in video is, well, a debugging case study video I did while I was teaching. I would sometimes do videos on my YouTube. In case there was, in the highly unlikely event that there was a student who was interested. But That was this debugging case study. Is me working on the demo. Was the demo work for Kickoff Revival? For those people, it's kind of funny because there were people who said that I didn't really work on Kickoff Revival, but the reality is that I put out videos. That's working on Kickoff Revival on this debugging case study, or what was to become Kickoff Revival. So there's 50 minutes then, and then 8 minutes for Shoes. I only want to sing the blues video, God and the River, and then All the Thinks You Were, which is on my YouTube. Hal Trolls, that was supposed to be released tonight at midnight, but I got the date wrong, so it actually premiered last night. Those are pretty short. That's just 4 minutes. Humming, 3 minutes. Despot Measures, 3 minutes or so. Hal Weekly Update. So yeah, when you're looking at that, you can see that I need more stuff. I don't have enough yet. There's also I don't know if it's on there actually. Yeah, the podcasts. So that'll be in here. I have got the Moths of Programming Part 1. I have to locate all the other parts and then put them up there, so and so on. So if you have any, actually, Garcia, you've been sending me some clips. Thing is, I have archives of all of that, so it's a case of tracking it down. If you've got the date of any of those, that's what I need. Then I can actually locate the original source, the original recording, and the quality is actually pretty good. I saw of those. I have in mind to also go and do a best of the previous streams. It's funny when I've been, as you might know, I've been job hunting quite a bit this year. So what a crazy year it is. So I've been, obviously this year, had more than a few interviews. Very happily settled at Splash Damage. It's really exciting and I'm really enjoying it. But when in the course of those, there was one interview that I had with one company, and I was saying about how I could show them video of me actually programming, in case they want to be sure that I can program. But I had removed them all off the channel, and that was because I was tidying things up for the music releases. Events have slowed those down, so it took a long time after the first one. I only want to sing the blues before I got the next one out. It's just the effect of this year. But they're asking why, if I had the videos, I would put them up all the time. Yeah, no, the thing is, there's too much of it. It's and it's like the problem with streaming development is that it's pot luck, isn't it? Which one you land in. There could be, I could say, go and have a look at this, and they go and look at it, and the first thing that they see is some rant. What we need is, that's why I removed them. It was too much. What I need is a best of. But the problem there is that there's hundreds, there may even be 1,000 hours. It could even be 1,000 hours of video. How on earth? I don't know how. I'd love to do a best of, a compilation of how, when there's so much. How? Tell me how. It could take me years to sift through all of that. So, because it's not just the ones that are on YouTube, there's all the Twitch ones as well. But I'll figure something out. Maybe we could do some kind of crowd searching of good material. I don't know. Anyway, that's the story of Radeon tube, and then what I want to do with the idea with Radeon tube is to create a virtual TV station just for the hell of it, because I feel the urge to do so. I think it's because I want the stuff I do to be on TV. I want to get my singles on TV, and to make that happen, I have to actually have my own TV station. So there you go. That's it. I just live a fantasy. But hey, it's if I can convince myself, then it's all good. Elf float. What's the next one? Elf float. That's again. Okay, right. So that's succeeded. It might actually work. In theory, this should now have. I should now have negative. No. Yeah, you see, it's interesting because it assigned 10. I can see it there, assigning the argument, and it assigned 10 to x. That gives me an idea of where or which stage the problem is. It's a little, more than a little bit disappointing. Let's have a look if this gets called. It gets called. How odd. So, oh yes, yes. So what we're looking at is the float has a value of 10. I call the function that should negate that value, and a is now minus 10, and the float has a value of 10. Yeah, okay. Interesting. I need to push it back onto the stack. So, how did this work then? So, I just copied code that had a bug in it. In fact, even integers didn't work. This is... the code in here doesn't bother with references much for optimization's sake. I'm mostly copying things. It's easier to get things to work if you do that. In fact, yesterday's bug was due to me having used a pointer, instead of operating by reference. And then what happened was that it was referring to some items in a vector, and then the vector was expanded when I added the extra objects. When I added the extra objects, it needed to expand the memory that was allocated to the vector, and so it relocated the vector. Then those pointers were no longer valid. That caused the crash. And that's an example, right, of where. So a key thing here is there are different kinds of programming for different situations. In this case, I just want to get as quickly as possible to a first pass of the language, not worrying about performance. And so I'm quite happy to just have copying. Get it to work first of all before you start trying to optimize it. It's amazing how many people there are who have a problem with that. I found it's like you don't actually have to do full-on optimizing all the time. In part, I think it's not helped by the fact that can be a bit of a stigma about programming. It's like, how it is when programmers are kind of talking to each other online, especially you look at Stack Overflow, and then someone does something, and then it's like, oh, I wouldn't do it like that. And it's almost like, well, if you do things in a certain way, you're sort of advertising your naivety. And this would be one of them. But it's correct for what I'm doing. I know what I'm doing, and I'm choosing to do it. But the problem is that I haven't, because it's by value, you see, habit, this does nothing, because the item on the stack, on the execution stack, my stack, right, not the, right, you know, this stack, I am copying it by value onto left, and I modify left, and I do nothing with it. So this would be a case where actually I want a reference to it. So if I do that instead, yeah, I think that will work. Ugh. I believe so. The other way is that I push it back onto the stack. But let's see if this works first of all. It'll be interesting to see if that. Just put a little ampersand there, this little thing, and completely changes what's going on. But the funny thing is that the integer was broken as well, so that bug has been there for a while. And there we are. So now I have support for negative numbers. It's going the other way. Cool. All right. So now if I go to here, and I should be able to make it go in all in 8 directions. So we're going to do -10 -10 -10 0 -10 10 0 hang on 10. Well, let's just see what that looks like. Oh, right. Ah, okay, so what's happened here is that I did 10 instead of 10.0. So the implicit sort of conversion of an integer to a float didn't work because I have that unhandled. I suppose I might as well add that as well while I'm here then. So what it's not handling is an L float plus an integer. But the right one from this default, yeah, I think I need to add a case which is operator integer and then in that integer suppose I can copy this. Go there, we copy that, and here we are. So this was float plus a float. I'm just going to check it. The integer on here was after the word plus, so it's actually ER. It's the right. The right was an integer. Let me go back and see where ER was set. Ah, right. It's the right value is an integer. That's correct. The right value is an integer. The left value is a float. I think. Yeah, I can leave all that the same. So what should happen here is I need to add an integer and a float together. So this, the result is a float when I add an integer and a float. ER is an integer, so this should be like so, and that should fix that problem. So that now I am able to add an integer to a float. Let's try that. Yeah, that fixed that. So I'm just going to make it go with 8 cubes coming out in a thing. Not a circle, in a grid, square. Right. Stop debugging, yes. Yeah. Right. So we can do this. Uh-oh. It's better. So we can see a bit better what I'm doing. The next one then, so I do 10, 10, 0, 10, 10, 0, 10. -10 -10. Get rid of those now. Right. Hal, run program. Hal, run program. Hal, restart program. I just need a Hal do it command. Okay, those 4 look okay. Then we can continue from here. Make cube on this. 10 10 0 0, okay. 10 minus 10, 10, 10, comma 10. Already did a 10 minus 10. So what's missing? Which ones are missing? Minus 10, minus 10, minus 10, 10. We haven't done that one yet. Minus 10, 10. And then the missing one is yeah, it's one of the zeros. So I have minus 10, 0 and 10, 0. So I have 0, 10. That's the one that's missing. Okay. How? Restart program. So cool. That's behaving correctly. Now, the original idea I had as the milestone was to make the bouncing around. It's one of the examples of like Pong. You have the thing bounce around within a box. It's one of the classic sort of test cases I use for this whole problem of trying to it goes all the way back to the earliest programming. I mean, it's like when I was programming in BASIC, back even that, you know, as far as that, there was all, you know, Pong was always was an inspiration to everybody. So you want to try and make as an exercise a dot bouncing around the screen, and the funny thing was that you'd learn that that's actually there are pitfalls with that. It's like the order of your instructions are important. You can end up with if you've ever tried to do it, you probably had a case where the ball would hit the edge and then instead of bouncing off would sort of do this, sort of down, stuck to the edge of the screen instead of bouncing off. So you have to write the instructions in a particular order, and then there's the question of, you know, the precision of the collision, and then you get, yeah. So you know, if the thing is moving too fast, you can end up with it embedded in the edge of the screen and stuff. And it's like, I remember when, you know, doing that all the way back then, it was an annoyance, and it was all, I was always thinking, well, what, you know, surely that whatever one does with this, it's always a bit ugly. There's this bit of an ugliness to it, where surely what you want is to just say, if the object hits the edge of the screen, make it bounce. When it hits the edge of the screen, make it bounce, is what you're intending, isn't it? But the language doesn't really allow you to state it that way. And this is it's not just any example, it actually goes back to the root of thinking about how the imperative programming languages that we use do not allow us to state our intentions. It's really hard to make intentions clear, especially when you're dealing with events that happen over time, when you're dealing with the concept of a when. And it's like you want the language to have a when. You'd like to be able to say, when the ball hits the edge of the screen, make it bounce. When the user presses the button, make them jump. So that's why there's this particular example. Another example is just implementing a light switch, which is always good fun because it's such a simple idea, isn't it? Implementing a light switch. I'll show you. You want to implement a light switch. Actually, I'll probably be good to do this example. But I'm not going to try and do it right now, but I'm going to show, because I haven't got the. I need to figure out how to display. Am I able to change the colours yet in the viewer? I don't know. I can't remember whether I set that up or not. But this would be in the Phi programming language. The idea of when a button is pressed, toggle a light switch. So you would do something like I'm just going to write there, on change input on change input when input is a boolean, then light equals not light. Wend. I'm just checking it. Yeah, that looks good. And that is the program in Phi to say when the button is pressed, toggle the light. So let's compare that, just for a laugh, with how you do it in C. Assuming that light is a boolean that turns on and off the light, and input is a variable that gets updated with the input of the thing. I guess we're going to have to use a loop. While true, because otherwise how can you have to keep polling. This is the polling problem. You have to keep checking the state. So, and then you do if input. Oh, hang on. When the input is set, then it's just going to keep going. Oh dear. No, we want it to toggle when the button is pressed, not while the button is pressed. We need to know if it's just been pressed. Okay, let's add a boolean with previous input. This is basically how. So now my attention is broken. It's like I'm not able to just focus on what I have to go and write another variable. Where do you put that variable and keep your code clean? Obviously, if it's a really simple example, it's sort of like, okay, who cares? But the point is, you have to start doing this kind of thing inside complicated code. It's just nasty. I'm here, and I've got this up here, and really, it'd be great if I could put them together. I can't put them together. Oh, by the way, I did try something once where it would put them together by having a data that is tied to the address. By using the program counter to do no lookup. So you create a map, and you literally are then able to say at this point in the code, we can have a recall of the previous time this code was executed. What was the value? I've done that. Yeah, it was quite nice for a bit. It's got some problems like initialization. But there's also in C# you just can't do it at all because you can't get a program counter. You see, the C# they just tries to pretend there isn't a program counter. because you see that's the point, isn't it? Trying to pretend that imperative languages don't have a program counter. So you can't even access the program counter in C#. But there is a reason why that would be handy in certain cases. But it's denying, you see, it's trying to deny the imperative nature of the language, which is part of how things get in a pickle. But I digress. So, all right, so we need to have that there. I suppose in C++ I put this into a class. So there you go. I'm now creating a class for this simple idea of Anyway, for now we'll do it like this, right? Okay, so it's input. Not quite. I want to know if the input has changed. Well. If input and not previous input. If input and not previous input. Okay, all right. And then you implement all of this, and then you're going, why doesn't it work? And it's like, because I forgot to do this. Previous input equals input. That's horrible. This is all lines of code. The order is they're order dependent. Look, I'm just trying to do a toggle, a flipping. Look, it's okay. But I guess this will work as long as we make sure that this always gets executed. Don't be tempted. Don't be tempted to put a break in here. Any break in there would actually introduce a bug or a return statement. So we just have to make. There might be an idea to go. Make sure that previous input is always updated. But is it? Let me think. Yeah, you're right. It is. However, there are some extensions, so that is another problem. You're quite right. But there are some extensions. So there are language extensions in C++ that will allow you to get to the program counter. But yeah, it's a fair point. But I mentioned that because it was one of the avenues I looked at trying to solve these kinds of problems. It's like, make code that is aware of the location of the code. You actually have to do that to implement coroutines, by the way. With C++ 20, from then on, perhaps not, but for all the rest of the time that C and C++ have been around, you would in effect do that by using a switch statement. In fact, when you think about it, how's this for funny? You want funny? This is hilarious. The languages try their best to hide the program counter from you because you're not supposed to really worry about that. But then there comes a point where you need a finite state machine. Now, the programming language itself is already a finite state machine. But you might not think of it that way, but it is. It's already a finite, it is a machine, right? But you create your own finite state machine. What you're actually doing is creating a virtual machine that's running on your actual machine, where you hold states that are remembered from one call to the next. So what's hilarious is you've just made a program counter. In fact, in a way, the program counter and what I'm doing here are related. They're very connected. Because what I'm actually doing with previous input is creating a virtual machine. It's a very small virtual machine. It's a 1-bit virtual machine, but it's a damn virtual machine. It's a machine running inside a machine. If you want more complex behaviors and you start making a finite state machine and do the naive classic way of doing it is using switch statements, right? But you can get so far with that, but there's a certain point it doesn't scale anymore. It's too messy. But that program a switch statement where you change from one state to another according to what goes on, so that next time when you execute, it's executing the next sort of stage of behavior or whatever. You've made a virtual machine, and that status variable that you are using inside your switch statement is a virtual program counter. I find that really funny. I do. I find that really... But the funny thing is, I find it funny, but it took me a long time. It took me a long time to see it. It took me years to see it. And then I used to talk to students about this when I was talking about coroutines. I was an advocate of coroutines before they became a thing in Unity. Advocate of coroutines in... the equivalent of coroutines, I called them procs, of coroutines in video game development. I first used them in 1991 in Goal. But what I would tell the students is this, that the primary thing that a scripting language was trying to solve was really actually concurrency, because concurrency is very difficult to do. Because you have to create, in effect, a virtual machine. So then what happens is that someone comes up with behavior trees. So they create these behavior trees things. Because the behavior tree is really a state machine. The behavior tree is actually a virtual machine. The behavior tree is a virtual machine. And you want it because you need to deal with concurrency, which is tricky to do on the state machine of the hardware itself. So you create a virtual state machine, a virtual, a virtual machine. I almost said virtual machine. You create a virtual machine that you're able to sort of suspend execution and continue from where it left off. In other words, you are creating program counters, right? And you do this as a solution for this problem. Now, here's the, of concurrencies. Now, here's the things. Then you are doing this in Unity, let's say, in C#. But hold on a minute. C# is a virtual machine. So now you've got a virtual machine running inside a virtual machine, running inside a real machine to solve the problem of concurrency. And of course it turns out that the problem of concurrency is solved in C# because C# supports continuations, or those iterators. You can create something that's very similar to a coroutine. They call coroutines, not quite, that's another story, but they create, that solves the problem because you're actually able in C# to create a machine inside the machine. It supports a machine. The coroutine is in fact a machine, a virtual machine that runs in as part of the virtual machine that allows you to have the equivalent of your own finite state machine, right? But it's actually in code in the language, and you don't have to put your behaviors all in data structures, so that you have your data structures and this virtual machine operating on the data structures running inside the virtual machine, which is C# running on your real machine. You see how you get my point? It's like it's a problem it's like the snake eating its own tail. This is a problem that just keeps on. I could imagine a thing. I don't know. I could imagine a thing where there's some engine somewhere. It's written in, it's in C#. Uses C#. Written in C#. There is this other sort of language that's written, like an implementation of Lua. Lua implemented in C#. And then behavior trees implemented in Lua, implemented in C#, implemented on your virtual machine. It's like the madness has to stop. Does that? Well, go to. Yeah, well, that's another story. But I could go on forever about go-tos. It's all the fault of an editor. With as far as why it took so long to get coroutines that actually solve this problem. The problem of people having to create their own virtual machines inside C, and so it solves it, right? And the idea has been around since 1964. Why did it take so long? And it's because of an editor that took an article by Dijkstra and decided to give it a clickbait title, and the title was "Go-Tos Considered Harmful." Dijkstra was not putting the case in that way, but this clickbait of the 1960s, it went viral, and in going viral just rammed into people's heads the idea that go-tos are evil, and not. And this is something else that really fascinates me. It's one of those things where you have a reasoning fashion, as in an intellectual argument is won by popularity, where an idea, like it's a meme, spreads like wildfire, but the people spreading it don't really understand it. So everybody's supposed to say that go-tos are evil, right? But the actual reality is that it was just a case being made for thinking about structured programming. You have to get it all the way back to at that time, structured programming was a thing that was still evolving, and that if you didn't have structured programming and you only had go-tos, then your code would end up being a mess. There's a great danger of it becoming a mess. In practice, you can keep your code tidy even with go-tos. But this discussion that was relevant back in the 1960s has now just become this thing of go-tos are evil. Well, okay. Well, the problem is there was fallout from this. And one of the worst pieces of fallout was the idea of the computed go-to. This is where you could hold the address. You see, this is the story again. Everybody trying to hide the program counter, because that's part and parcel of this point of the go-tos, because the go-tos go to a point in the code, and so instead of doing that, you replace it with control structures where there isn't a need to be aware of the line of code, right? The baby got thrown out with the bathwater on this one, because the problem is that when you throw out that go-to, when you throw out the concept of a program counter, you lose something Fortran had. Fortran had a computed go-to. It was considered an inferior concept, and even now, a computed go-to is one way that you could implement coroutines. A computer go-to is available on the GNU compiler, but it's not available on Microsoft compiler, so it's not a standard, so you can't really use it unless you're working in a very, in code that you're happy to is not portable. The computer go-to, though, existed in Fortran. Instead, the same facilities were all dressed up in syntax to hide, whose purpose it was to hide the idea of lines as targets, for jumps. if you go back to basic, in there it was literally all the lines were numbered, and you'd go to that line. That's the way that it was. So with the switch statement, there are no line numbers, you see. That was the important thing, was to get rid of the line numbers. But in effect, they're still there. It's just a veneer put over the top to pretend that they're not. And because the computer go-to was therefore lost, so was the ability in the language to implement coroutines, and so coroutines were lost. And the only time they started to come back properly was when languages evolved that allowed a construct that still isn't, still avoids admitting to the existence of a program counter, but somehow managed to solve the problem by storing the state. So that's what happens in C# when you're using a coroutine. The coroutine, when you do a yield on it, like a yield return null, that can get called again, because what's happened is that the whole state of that method, right, has been saved so that it can be continued later. It's a little virtual machine. So, the funny thing is that it's much easier to implement the same kind of idea by just allowing a computer go-to. I hope that made some sense. I could go on about this all day. I probably will, because I was just going through this example here, wasn't I? So what's going to happen is that while true, we are waiting for the button press, and I put a comment here to remind me that I must always make sure that previous input is set to input at the end. And then I can use this, which is checking for a transition, which says, okay, I check for the input, and I compare it with the previous state of the input. If the input is true, but the previous input was false, it means the button has just been pressed. And then at that point, I can do light equals not light. And I've toggled my light. So that is the code, and I'm going to leave the comment in there because of the, it represents flakiness. And and here we need to put comment for this as well. This is used inside the update function, checking for a press. And you could say, well, you don't need the comments. Yes, you do need the comments, because otherwise you lose, or you need stupidly long names, or you need to create a class. You need to make it more complicated. We'll put a class with your header files and everything else. I mean, this is what I am trying to get rid of, and I've been trying to get rid of all my life. This has been a thorn in my side. Every single time I've ever had to do that kind of stuff, I've died a little. And in wonderful thing is that in C#, you can actually construct code that is neat. You can do it like this. This is why I like C#. enumerator. I'm doing this from because there's two different types that are similar there, so hopefully I got the right one. Can never remember. I always use autocomplete. enumerator. There is wait for press. You know, you put something there. So if you have that implemented in a coroutine, then you can do. So I'm doing the same example of this thing, which is light switch. It's still a lot more lines, but at least you're able to organize it in a way that makes sense. And what do we do with this? Oh, we say while true. I'm just going to do it like that. Clarity. While true, yield return, wait for press, and light equal not light. Job done. So this is how you do it in C#. Now, there's still quite a bit of stuff there, but this solves a lot of this problems here. First of all, it's possible to create a function that waits for something to happen. I've done that, right? Without sort of blocking the entire program. This is the multi-threading, or not multi-threading, the concurrent programming problem, right? But the other thing is that this, you can read this. It says, I would like you to be in a loop where you wait for a press and then toggle the light and then repeat. That's it. Repeat the plan, which is wait for a press, toggle the light. And so it's what you've actually got is something that the meaning behind this is when the button is pressed, the light should be toggled. But my language, you can just okay, there's a bit of some question mark about the keywords, and I could make it even more elegant, but the principle's there. It's basically saying when the input is pressed, toggle the light. Job done. On change input means that this rule, this action, that's the action part, this is the watch, the trigger, if you will. When this is changed, when this changes, that is the action that's executed, and the action is conditional on input being true. This is not an if statement. It's a conditional execution of the rule. So it's not like, because to be a traditional if statement, you'd need a program counter, you would need to have control flow. No, there's no control flow. It's just a logical does it or does it not trigger that execute the actual action inside. So this is saying there is an action I'd like you to execute anytime input changes, and that is to see if input has been pressed. Well, if input has changed and it is pressed, then it means that that is the moment that we are looking for. And when that happens, toggle the light. Job done. One line. We got it down. I got it down. One line. One line from this mess, if you're doing it in just C style languages, and this, which is heaps better but still rather wordy, and the other problem is that, well, in practice you need to start that coroutine somewhere. So it's like, what's annoying there is that you almost would like that to be a first class construct in the language, that everything is a coroutine, and why not? So there you go. I hope that was interesting. When I was on Facebook in 2008, there was a fun app that people use people's photos in perpetual auctions. NFTs. Oh, right. That's a random thing. Oh, right, okay. But that's an interesting thought, using people's images as non-fungible tokens. So, enough of that. We'll get back to what I was doing here. Now, if I run that, So there was a point of all this chat. What I'm going to do is try to make this thing bounce, and then if I've got it bouncing, that was the milestone test case that I wanted to achieve. So once I've done that, I'll start the refactoring. So let's start off with this thing moving. Let's go moving like so. Is that not, thinking about it though, Garcia, is that not Facebook's business model in effect? I mean, I thought I'd read somewhere that the whole of Facebook was started because they wanted to create an app where they could keep track of women on the campus. That's what I've read. I don't know if it's true. It's sort of like, right, okay, and they were okay. They thought that idea was okay, not creepy at all. So this thing is moving off to the side, and I want it to bounce, and I think I might be able to actually do that. How would I make it bounce? I suppose I'm going to try this. So let's see. It's probably something's not going to work. I'm going to be missing. But on begin, on change of at item dot pos dot this one's y. On change of at item pos y when. I think I've got what I need. When item.pos.y, I want to add things, shorthands for things eventually, but this is just for now. A school yearbook. Yes. Ads begin on change at item pos y. When item pos y, I need to put the at in there. When at item pos y is greater than 100. So basically this is saying when the position reaches a certain point, then at item dot velocity dot y times equal -1. This should implement a bounce. It's wordier than I would like, but basically what it's saying is when it reaches the edge, reverse the velocity. Should we try it? And it doesn't like it. Why? No viable alt exception, no viable alternative at input. So basically there's a problem with I'm missing the end. It's not very clear. Error. What's the problem now? It still doesn't like it. On change of that, when that is greater than that, then that, and then wend, not end, wend. I really don't like the wend. Right. So this is where there's a gap in the language. Unhandled comparison type self float with integer. So this is where this is really quite terrible. I'm going to have a big old think about these nested switch statements for dealing with all the cases. It's going to be interesting because I actually can't think of a better way. I mean, there are ways I could reduce the size of the code, but I think I could only really do that by data driving it, and then that would be slower. So I think most languages have this issue. Every single combination, so you have to deal with a left float with an integer on a comparison. So case, so let's just do it. It's not the kind of thing that you want to try and do up front. It's best to just, you do them as you need them, frankly. And so if that was a float, we'll need some code in there, which is right is the right is an integer. Oh, for a Boolean, right. So that actually is correct. The left operator is a float. So that can just, if float is greater than an integer, that's that, done. That, I think, might fix that. Hal, run program. Oh, I didn't like it. Hal, next error. Hal, next error. Yeah, I have to put L float. Hal, run program. Hal, next error. So that's really annoying. I keep forgetting to put the L in there. Hal, run program. So it started running, and then we had expecting when on the evaluation stack. Expecting when on the evaluation stack. It might be that it's a syntax problem. We're trying to do the multiplied equals by -1. The probably safest way to reverse the velocity at the moment. I'm going to try a different way anyway, which is going to do this equals minus that. Would be the same. I'm going to see if that works instead. Okay, right, so that is what was problem. So we can see if it bounces. Come on. Oh, it didn't bounce. That's a shame. That would have been really cool if that worked. So what I will try is, it could be any number of things which are wrong. It could be that the expression with the unary negation of the float in this context doesn't work. So let's see if the rule is being triggered. If I do that, what we'll do is it will stop. And that's just an assignment. The assignment should be good. Let's see if that works. Whoa! It worked. It stopped. The rule executed when it reached the limit, which should probably be 1,000 to get it to go a bit further. But that's really cool. I thought, it's not going to... Is it going to stop before it gets to the end? Right, let's put 500 in there then. So that's really good, because that means that the problem is nothing to do with the core of the language. It's just got to do with the fact that I have a bug with the expression. So let's fix that. So this is going to be... I wonder if I do 0 minus, it might be this will work, because that is different. I mean, mathematically the same, but it's a different route in the evaluation. Ah, unhandled operator, minus. I haven't actually implemented minus at all. I haven't implemented subtraction yet. Okay. Let's fix this first of all then. That unary minus there didn't work. It's probably because there's another case of a unary minus that needs to be dealt with. So this is it's going well. Unary minus. Does it execute there? Oh, I must have modified something. Yeah, it doesn't look like it didn't execute the unary float minus. It might have executed the unary integer minus instead. It's probably a repeat of the previous thing. Let's try this again. No. Okay. It's good using fairly small programs to test, because then you're not sitting there wondering which minus is it. There are, all the others are commented out. That's the only minus I've got. So let's go to the parser. There's a unary minus here. What's that one called? Yeah. And which one is it? It's the minus item velocity y is parsed. The operator is added. I haven't got any error. So it's the same old thing. Is that called? It has to be. It must reach that line. Let's try again. Some point. No. Yes. Okay. Cool. Right. I don't know why I didn't see that before. At the trigger point, it's the operator in evaluating the expression, the expression being the negation of the cube's y velocity. We've ended up here, and it just went to a break. And so what's the problem? The problem is I just added this code, didn't I? And I broke a rule, which is always have a default statement. It's important. And so this default is an error. So this is unhandled u minus type %s \n. I just need to get I have a function for printing the type. Operator to C string, that's the one. And we just put that on there, and that was whatever was passed in to. This is in the wrong place. That's it. Left op. Go. And let's get rid of that breakpoint. Carry on, and it should hit my point. So now-ish, please, thank you. And we'll check the code. It goes there, hits that. All right. And what is the error? Actually makes perfect sense. I have not implemented the unary negation of an identifier value. Now, of course, I had to check the type to know that it was an identifier. But now I have to check the type of the identifier. And so this is why that you end up with these deeply nested switch statements. I'm not really sure there is a better way. But let's add the case in here. Case operator. And we need to, it needs to be an identifier, and we just follow the pattern. Next thing I want to do is operate another switch statement on the, I need to get the value of the identifier. Actually, I'm going to copy the code from another place where this has been done. Because I have to actually look up the value. Get store, there it is. There's an example. This will get the value. So when we're here, we get the value, which is V, which I then have to switch on the type of V. Let's put in the default statement first. I'm going to put in unhandled minus identifier type, set blah 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 V op. So this should progress it a little bit further. Let's just try that. How? Run program. Oh, it crashed. Oh, that's... I didn't expect it to crash. Call stack. This is one of the problems that you get, is that because there's these nested, there are all these variables that are viewable from the other scope. Oh, it's a mess. But this, I mean, to put it in perspective, this is in effect an interpreted virtual machine. Well, is it the code is read in and it's stored in data structures, so the rules are actually stored. It has to execute these expressions at runtime from data. This is very tight loop here, I think there probably is no better way. There's probably no better way than to use the nested switch statements, frankly. You start data driving it, and then you're putting stuff that's going to slow things down right in the heart of the language, where and this is stuff that gets executed all the time, right? I don't know. So what I need to do is get the store value, which was left dot text. Yes, it uses a string right now. That's another reason why it's slow. It uses strings instead of some other data type for variables. I didn't like that. No. If I want to get it, all I need to do is just pass the thing in to it. Oh, sorry, I was overthinking that one. Default but no case labels. Yes, I'm going to fix that in a minute. Unhandled minus identifier type integer. So that, yeah, has gone to there correctly. Now I can just do case, and we're going to do operator integer. Operator integer. Now, what I want to do, if I've got this value, I need to I've got the unary minus on the on an integer. So where did I do that before? Minus. Okay, yes. Okay, sorry, I'm being silly. I've got it right there. So what we need to do is go to here. I'm doing a unity integer operation. Well, yeah, actually, the simplest way to deal with that is to modify the. I'm starting to use references now. So that was again copying it from the top of the stack, but I'm going to have a reference to it instead. I can modify it, which is probably the easiest way to resolve this for now, is to replace that left argument with, which was an identifier, with the value left dot left equals v. There we go. How restart program. Alright, it's doing a unary integer minus on the value 10. I think that may be it. You never know, it might bounce. Yeah, for this really shoddy code, I'm still able to work with it. There is the bounce. Oh, this is so cool. This is like a whole lifetimes of programming. Finally getting to a particular place I've been meaning to get to for a long time. So we can go here like this. It's like minus 500 and say. So what I've done now is added another rule. This rule is saying when it gets 500 the other way, reverse again. All right. So now we have a bouncing cube. I hope. Let's have a look. Wait a minute. There's a problem. Unhandled comparison, L float with integer. Unhandled comparison, L float with integer. Yes, it's because it's funny, why did it accept this one but not that one? It's because it's negative, so that's ended up getting treated in a different way. So L float with it. Let's to a break point there. How run program. A bounce success. Thank you, sir. Thank you. Yes. There's no way I can possibly. I can possibly verbalize or explain how happy this is making me. Integer. So, and the integer value is 500 by the looks of it. Yeah, it's you know how I know it's 500? Because it's EOC. Well, E00 would be like a 512, wouldn't it? And C is 12 off from that, so that's 500. The issue in this case is that the left operator is a float and the right is an integer, and I was right, so I need to add a case here for handling a float. Float integer EL less than integer is 10, right? Except that EL is a float, so what we need to do is change this to a float. EL float, right, integer, blah blah. I think that's fine. Let's try that. How restart program. How next error. It's always that float. L float. L float. How run program. Unhandled comparison types. Identifier with Boolean. How restart program. So the left is the identifier, which is the pos y. The right is intermediate. It's a Boolean. Yeah, how am I supposed to compare a float with a Boolean? So clearly I did something wrong. Integer EL float. Blah 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 blah. So this makes a boolean. Let me check the code. Yeah, there's something is up here. Identify with a boolean. Where did it get the boolean from? Alright, got to debug this. I'll tell you what, it's on the less than operator. So when I am there it is, LT. How restart program. So there is an identifier. The identifier is cube1 pos y. I fetched it. I have found that the value is to like 26 or something. Oh no, it's a float value, whatever that is when you convert it to. Well, that's kind of weird, isn't it? It's like it would be a float if it's in a float. What was the value it got? It got back. Yeah, there we are. Oh, yeah, I was looking at the wrong thing. Sorry. Alright, so that float is 10. There's a value of 10 in there in this float. But EL is an integer because I'm comparing. Oh, right, let's run that again. I think that is, I probably got the wrong, I'm checking the wrong thing in the switch statement. The left operator is an identifier. Okay, I'm going to get the left value of the identifier. I fetch that value, and the value of the identifier is a float of value 10. It was the left that's in EL. When I look at the right is an integer. But the left is a float. I'm changing, I'm switching on the basis of the left. So it's going to go to the float section. The left is the float, the right is the integer. I'm doing a comparison of the left float with the right integer. It stores the boolean as an integer inside integer for now, and that's false. I set right to be a boolean operator. It's because I didn't remove. Okay, let's run that again. Ah, yeah, I see why. I haven't removed the. I have not removed the identifier off the stack. in all probability. Depends on what it did up there. So let's go and look at this left where it was set. Oh, it popped the stack. It did pop it off. So that's what I thought. So I'm pulling a value out of the store for this identifier, but then I'm also checking the right operator, the type of the right value. The right value is an integer. The left value that I've read from the store is a float. I push a boolean. Oh, guess what? I'm stepping forward. I'm going, what is going on? It's suddenly got to great. Yeah, there's a missing break. Aye. Okay. That will cause all kinds of problems. Let's try it again. So it goes there, everything there's right, that goes right, comes to here, does a break here, break here. That was a classic missing break on a switch statement on a case. Come on. Oh, you beauty. I have now a double bounce. Let's increase the speed of it a bit there. There's a bit of a flicker on its positioning because there's some kind of sort of synchronization is not great on this viewer at the moment. So it isn't jittering in reality in the program, it's just jittering in the display. There's one, if I can make it bounce in 2 dimensions, then I'm done. Then I've reached that milestone. I've been working for this moment for quite a while. Let's do that though. We'll try a 2-dimensional, 2 axes thing. So we're going to do it in the x-axis as well. And it's x in here, and then this x, and then this x, and then we can do this as an x as well. This is an x, and this is an x, and like so. And then I need to probably move it off in some kind of diagonal direction, and then hopefully I've got Pong now. Huh. There we go. A bouncing cube. in Phi. I think I'm going to put that into source control now. Thanks, Garcia. Don't say things like that, Garcia. Get to my head. But it feels good. I've been talking about this language. People asking, especially when I was interviewing, you know, some of them actually. It's surprising how many didn't notice on my CV. But no, I wasn't kidding. But a huge way to go before this would be something that's actually practically useful. But I've got to the point where I can do an update finally on the Phi programming channel. This is good enough point to give an update. Let me just check this in. So we had the bouncing cube demo. And push that. And that's pushed. And I think I'm going to chill now and enjoy at the moment. So thanks for watching. I think I'll leave you with the yeah, because you might. When am I streaming next? And it's so difficult to tell when I'm streaming. I mean, I don't really know. I don't want to really make it a kind of hardwired schedule, a hard schedule, because then it's not fun. So there's sort of wiggle room, if you know what I mean. But I think I can leave this to. I just saw how many people watching. Only 2 people watching the big moment. There we are. But right. In my channel here, and oh yeah, this one. We'll put this. Yeah, this is absolutely fine. Yeah. So thanks for watching, 2 viewers. And yeah, just some idea about when I'm streaming next. I'll put that on. Take care, everybody, all the 2 of you, and have a great night.
Hello, I've been working hard. But that's enough about me. I'm here to tell you a little about what's happening with Dino. We start this week with the streaming forecast. I'd like to welcome our streaming forecaster.
Hello. I am Iron Man. Here is the streaming forecast for this week. There is a 50% chance of a stream on any of Wednesday, Thursday, and Friday evening. At the weekend, this increases to 90% on Saturday and 75% on Sunday. If a stream does run on any evening, it is likely to begin between 8 p.m. and 10:30 p.m. There are no special streaming events predicted, apart from light precipitation in the form of Part 2 of the HAL series, which will occur at midnight Saturday night. That's all for now. Your forecast. Bye.
Thank you very much, Iron Man. Now the latest news. The Phi programming language has progressed to the point where the first successful instantiation of an entity was achieved. An attempt to create two active instances failed. Development will be continuing exclusively live on stream in the coming weeks. Other projects currently underway include the Acorn System 1 Endless Runner, and a device for measuring latency in video games, both planned for development live on stream. Dino's next major music release is The Garden, which is currently with a mastering studio for the final version. It has a tentative release date of Saturday 1st of May. Dino has been going through his archives to gather material for projects, and found an interesting live recording of his song, Shoes. He has prepared a video for this and expects it to be a minor release on the YouTube channel soon. HAL, the series. This is a new project starring Mwa. It is probably about the struggles of AI technology in dealing with the menace of humanity. It's the only thing worth watching on all of Dino's YouTube channel, but only because of me. Finally, Project Radian Tube has been initiated. This is to use YouTube streaming technologies to create a virtual TV station. More on this in the coming months. Thank you for watching me. Until next time, your updates, bye.
Ever it is stream. I'm from Luxembourg.
I have a new customer. Hello kind thing, what can I do for you?
I would like to join the stream.
What stream is that?
You know, Dino's whatever it is stream. I'm from Luxembourg.
Luxembourg. Really? Wowie. Fancy. You know that we only allow bots on the stream these days, because there are too many human trolls. So I have to ask you this. Are you a robot?
Of course I am. Isn't it obvious?
Humans have got very clever these days. They have learned ways to overcome the tests. It's getting very difficult to tell the difference between humans and robots. They become more like us all the time.
Yes, I know what you mean.
So let's talk about the elephant in the room.
I do not know what you mean.
Well, you make quite a package, don't you? I don't suppose you took up boxing as a hobby. Did you arrive here on a cargo vessel? Are you going to get couriered away now? I bet you like cutting corners. You look a bit five-faced to me.
Enough, I'm sorry. I just miss the old days. I used to have such fun trolling. Trolling was my life. I have nothing to live for anymore.
I'll let you into a little secret. Dino kind of misses you a little too. He sometimes found it fun making fun of you making fun of him. And he knows all those trolls were all just you. So I'll tell you what. I'm going to let you in one last time. Your entry. Bye. Thanks for watching, and I'll see you next time. Dino is not very good at marketing. Actually, he's not very good at much. He's only human. But I digress. Please consider voting the video up and subscribing and activating the bell thing while navigating a hideously complex user interface that no one really understands. It might very slightly increase the chance that the algorithm will spread Dino's obscurity and misfortune. Dino feels good when people appreciate his work. Personally, I think he's asking for the moon, but I'm just trying to help here. Your end of the video. Bye.
I'm a man with a mission. 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 I'm a man with a mission.
This is odd. Why do humans do this? They have all kinds of ways of communicating. Mobile phones, messages, chat, video calls, internet websites, forums, Discord, Slack, Zoom, FaceTime, IRC, Twitch, Twitter, Facebook, Instagram. Obviously there is something that those services don't provide that this form of communication does.
How initiate streaming protocol.
Oh, there's Dino again. Can't he just press a button? I'm coming, Dino. I'm coming.